Let's get ready to have those notebooks out and open. This video is for Mr. Markey's Algebra 2 CP classes. It is in regards to the exponential project. I would like to give you an explanation of the project as I attempted to do in class and would have done over these next few class periods had we not been quarantined by the coronavirus. So here we go. First up is the bank. Now, as you can see on the project sheet, you've inherited $10,000. You are to be researching 3 different banks. Now, I'm going to be walking you through what is expected of you for TD Bank. I'm going to insert some screenshots of the TD Bank website along the way to help as a reference point. Again, you are not allowed to use TD Bank. You have to research 3 different banks. Each bank should provide for you a different interest rate. You cannot use a CD, a certificate of deposit, to get a higher interest rate. You have to make sure that the $10,000 that you inherited meets the minimum requirements to have that particular savings account. So the TD Bank account that I have for you to show is the Growth Money Market account. Now, the Growth Money Market account, for the sake of argument, earns you an interest rate of 0.15%. And I'm showing that screenshot where we can meet those minimum requirements. If you're going to put the 0.15% into the compound interest equation, you cannot put it in as 0.15. You're going to have to change it and convert it to 0.0015. Now, the principal amount of money that you have is $10,000. Now, TD Bank doesn't advertise this, so you would have to dig for it if you were researching TD Bank. But a quick Google search would eventually show you that TD Bank compounds monthly. Now, what that means is that TD Bank compounds 12 times per year. So we need 12 to go into that equation. Now, the value of t in the compound equation formula, for the time being, I'm going to leave blank because you're going to have to do 3 different setups, 3 different calculations for each of your banks. And the value of a is going to be the resulting amount that you would have after the calculation. The formula that we need, that we have written into our notebooks, the compound interest formula that most banks typically use. Now, for each bank, you're going to have to show the setup to the calculation for 10, 25, and 40 years. So let me show you the explanation for 40 years. If you had $10,000 deposited into this growth money market account, compounding monthly at a 0.15% interest rate, and you left it there for 40 years, this would be the appropriate setup to that problem. Now, when you are typing this into whatever calculator you have to make sure you do this carefully. When you raise to the exponent of 12 times 40, it would be a good idea to put 12 times 40 in their own set of parentheses. I'm going to show you a couple different ways in my calculator in a moment. But the rest of it should be a pretty straightforward calculation. So on my graphing calculator, I can do 10,000 parentheses 1 plus 0.0015 divided by 12 to the 12 times 40 power. And again, notice the 12 times 40 is in its own little set of parentheses. You could also do the calculation with, instead of the 12 times 40 in its own little set of parentheses, you could also do the calculation with 480, because that is what 12 times 40 is. Now what that tells me, and again, we're gonna round up just for regular rounding rules. Banks typically round down, but we're going to round up. But what this tells me is that after 40 years, your $10,000 would only amount to about $10,618.33. Not really a lot. But dems the brakes when it comes to banks. Now, let's talk about the $1 million calculation. After you do the research into all 3 banks, you are going to choose one of those 3 banks. Now, obviously, you would hopefully pick the one with the best interest rate. Sometimes that may not be the case. There may be other perks and extra things that banks would potentially offer you on top of the savings account, but let's just go with the one that has the best interest rate. You'll have to show the actual calculation for 10, 25, and 40 years. But then the question would then become, how long? How long until your bank account reaches $1 million? So this is after 40 years. But let's do the calculation for $1 million. In this particular setup, because they're asking how long until you reach $1 million, you don't know the value of t, but you know everything else. So how long until we reach $1 million? Now, if you notice right here, the t is the unknown, and we eventually have to get t by itself. Now, there's a couple different ways to do this calculation, but my suggestion to you, your very best bet would be to divide both sides by 10,000 as a first step. If you divide both sides by 10,000, you're going to get 100 equals, parentheses, 1 plus 0.0015 over 12 to the 12t power. You could, if you wanted to right now, evaluate the inside of the parentheses. You could. You don't have to. I'm going to show you both ways to do that calculation, but again, you don't actually have to evaluate that. But just so you know, exponential form is y equals b to the x power. Now, if we're doing y equals b to the x power, you could always convert that to log form. Log form allows you to get the exponent by itself. The log always has a base, a little subscript. And eventually you get that x by itself. For our problem, we're going to have to convert this monstrosity. But keep in mind that you are going to get the exponent by itself. So, here's what we get. Log base of this monstrosity, the exponent is by itself. The 100 goes in the parentheses. Now, if you were going to use the change of base formula, which I'll set up on my formula sheet in a moment. Now, the change of base formula, if you had log base b of c, log base whatever the heck it is, you can't evaluate that on your own. You can't evaluate that unless you have a fancy calculator that can change the base for you. If you just have a regular T83, or if you had a scientific calculator, or if you had the online calculator, they typically just use log. So you're going to have to change the base in what you're typing, but you can't change the button on the calculator. So, change of base formula. Again, as I said, the base goes on the bottom, and this will take care of that evaluating. That'd be log of 100 divided by log of this monstrosity equals 12t. Now, on our calculator, what would that potentially look like? Zoom in just a little bit. There we go, there we go, there we go. On our calculator, that would look something like this. Log of 100, make sure you close the parentheses, divided by log of 1 plus 0.0015 divided by 12. You could type that whole thing in at once. Now it gets us this terrible number. Oh, but keep in mind that this number is equal to 12t. Now I can do that calculation again. I'll do it right here for you. There we go. Where you could evaluate the 1 plus 0.0015 divided by 12. You could evaluate that right at the very beginning of the problem if you wanted to. If you did that, you would get the following decimal, which converted to log would look something like this. See, that decimal, 1.000125, is equal to this inside of the parentheses right here. In fact, I'll show you that right there. There it is. 1 plus 0.0015 divided by 12 equals that decimal. If you were to do the change of base formula, remember, when you do the change of base formula, you have to put the base on the bottom. Still equal to 12t. If you do that calculation, you should end up with the same terrible 36,000 number. I'll show that right here. Log of 100, close those parentheses, divided by log of 1.000125, and you still get that same terrible 36,000 number. Again, not our answer, because that 36,000 number is equal to 12t. Regardless of which situation we do, zooming back out just a tad, there we go. Regardless of whatever situation we end up doing, we have that terrible 36,000 number. 36,843.66 is approximately equal to 12t. Of course, you have to divide both sides by 12. If you divide both sides by 12, you get t is approximately equal to 3,070.31. Now remember, t for the compound interest formula is always measured in years. This is how long it would take until your $10,000 would become $1 million at TD Bank. Make sure for the bank you have the evidence of the interest rate. For all three banks, and make sure you show me the work that you did. Of course, you could do screenshots, scans, whatever you need to do. The math work can be handwritten, but just make sure it is neat and clean. Okay. In regards to the car, according to the project, there are certain rules that you have to abide by. The car must be at least 3 years old or older, and the car must have lost value over time. Now, there are certain ways to check this. First, find a car. Make sure it adheres to the rules of being at least 3 years old. There are a number of websites that you could potentially go to. The key phrase in this entire project is evidence. I need evidence of the things that you were finding. So find a car listing. What is it being sold for? Now, when you provide that evidence on your project, again, I do not want links. If I click on the link and then the car is not there because it's been sold or the listing has been taken down, that's on you. Take a screenshot. Take a screenshot of the listing. It will have the year, make, and model of the car and the current value that it is being sold at. Now, the current value obviously is a subjective statement, but that is okay. As long as the current listing is there, we're good. Now, the listing that, and I'm looking for this right now, the listing that I wanted to go over with you, I wanted to search for a geoprism. And the one that I found right here, and this is the one that I did in class, I found a 1994 geoprism LSI. What I need in terms of this 1994 geoprism and the listing that I'm sharing with you right now is the tag price. Now, the tag price is the current value of the car, which means that when it comes to our decay formula, the value of y is the current value of the car. The value of y is the current value. It is the resulting value. It is the resulting value after a certain number of years. And since it is a 1994 geoprism, then it has been 26 years since this car was made. Now, obviously, that's not exact in terms of when they actually make the 94 geoprism, but we're just keeping it simple for ourselves. We do not know the rate of decay. The rate of decay for every car is going to be different depending on where you drive it, who drives it, how well you maintain the car, whether it's been in any accidents or whatnot. So every rate of decay is going to be different. But when it comes to the original price, the A value, you need to remember the letters MSRP. Manufacturer suggested retail price. This is the best approximation for the original value of the car, the initial value of the car. Now, as I am literally writing this, I am just going to do a quick Google search, and I am going to screenshot this for you. 1994 Geo Prism LSI MSRP. Boom. I have something pop up from autotrader.com. And again, I'll screenshot that for you, my Google search. The MSRP of this particular car was $11,840. These three pieces of information will allow me to find the rate of decay of my car. Now, I'm going to have to do a bunch of calculations after the fact, but we'll deal with that when we get there. First, let's find that rate of decay. First, let's set up our formula. 995 equals 11,840, parentheses 1 minus r to the 26th power. We need to solve for r. Now, this is stuff that we did back in Chapter 6, when we did fractional exponents and roots. That's the stuff that you need in order to solve this problem, because you have to get that r by itself. First thing I'm going to do, I'm going to divide both sides by that 11,840. Yes, it's going to give me a terrible decimal, but I'm not going to worry about the terrible decimal. Instead, I'm going to leave it as a fraction. Temporarily, I'm going to leave it as a fraction. Next, I'm going to have to get rid of that 26th power. Now, you could take a 26th root, but I think in terms of typing it into the calculator, it might be a bit easier to see if we raised both sides to the 1 over 26 power. If we raised both sides to the 1 over 26 power, that would allow us to visibly see the fact that this we're starting to get this r by itself. If I raised this side to the 1 over 26 power, and I raise this side to the 1 over 26 power, then, well, the 26 would go away. Now, I have to calculate this, and I'm going to show you how to do that on the calculator. But keep in mind, r is still not by itself. We're looking to find the rate of decay of this particular car, the 1994 Geo Prism. If I were to evaluate the left side, this is where your calculator will come in handy. Parentheses 995 divided by 11,840 raised to the 1 over 26 power. Now, again, I've said it since September, parentheses will save your life. You need to put that fraction in its own little set of parentheses. Otherwise, this thing will screw up. Now you get a number here. These numbers doesn't mean anything to you just yet, but this number is equal to 1 minus r. Now, I'm going to write this on the piece of paper in a moment, but you still have to subtract 1 and then divide by -1 in order to get that r by itself. I'm just going to do that in the calculator here so you can see it in real time. Subtracting that 1, dividing by -1, that is my rate of decay. Let me write this on paper. First, I get this decimal. 0.909 is approximately equal to 1 minus r. I subtract the 1 from both sides. Still, that negative is on my paper. I have to get rid of that negative. Divide by that negative. R is approximately 0.091, which is 9.1%. What that means is that the 1994 Geo Prism lost about 9.1% of its value per year for 26 years. And that's how it went from $11,840 down to $995. We're going to need that number for some of our later calculations. Now, you're going to have to figure out what will the car be worth 5 years from today. There are two ways to go about this calculation. You could go, well, better yet, I'm going to show you the comparison between the two. I think that would be best. Using the original price of the car, the MSRP price of the car, this would be the calculation for 5 years from today. Now, I'll do that calculation in a moment. But I wanted to point out that this is the original price of the car in 1994, which means 31 years later would be 5 years from today. This would be the year 2025. You have to use the rate of decay that you found. Sneak a little 1 in there. Use the rate of decay that you found from the previous part up here. Now, you could do it this way, and I'll show you what that price is. But you could also do 5 years from today using today's value. Now, today's value is $995. There is going to be a little bit of rounding error, and we'll deal with that in a minute. But if you have the initial number set as 995, it would be 5 as the exponent, meaning 5 years from today, 5 years from 2020. Now, you don't have to do both calculations. You just have to show me one of these calculations. But I wanted to show you, here we go, using both calculations here. 1 minus 0.091 to the 5th power gives you approximately $617.51. And then using the MSRP price, there we go, $614.94. Now, obviously, these numbers are a little different because there is a little bit of rounding, and you're dealing with such detailed information that, yeah, you're going to be off by maybe a couple dollars here and there. That's okay. You only have to give me one of those calculations. I'm just showing you both right here. From the $995 range and from the MSRP dollar range. This would be the value of the car in 5 years if the 9.1% rate of decay were to continue. Now comes the big question. How long until the car is worth nothing? Now, based on what we've learned in class, because of the horizontal asymptote to the car, or to the equation of the car, this car can never actually be equal to 0. It never will be equal to 0. Now, notice I said equal to 0. It can still be approximately 0. It can still round down to 0. The question is, when will it be worth 0? Now, again, you can set this up either from the MSRP price, or you can set this up from the $995 price. For my purposes, I'm going to set it up from the $995 price, because this would be how many years from today that this thing would be equal to 0. Now, let me show you what you should not do. What you should not do, you should not put a 0 here. If you put a 0 here, the calculator will not give you the correct answer. If you put a 0 here, the calculator is going to give you an error if you try to go through the math to get this thing done. Ultimately, and let me just show you what the calculator would say, if you did this with a 0, at some point you're going to have to do a logarithm of 0. It would look something like log of 0 divided by 995 parentheses, divided by log of the base. And if you do that 0, boom, you're going to get an error. You can't do log of 0 because the value of the car will never be equal to exactly 0. So instead, we are going to set this equal to 0.005. The reason being is because 0.005 would round up to a penny. And after it crosses that threshold of 0.005 and goes below that value, then it would round down to nothing. That's the general idea. So we would solve this the way we normally would. We got to solve for the x, so logarithms will be needed at some point. I got to do 0.005 divided by 995. Again, crazy decimal. Don't worry about the crazy decimal. Leave it as the fraction for the time being. You could leave this as 1 minus 0.091, or you could just put 0.909. Which is the actual calculation. Now you can convert to logarithms. If you were, the base on the exponential is underneath the exponent, and that is the same base that is on the logarithm. The whole purpose of logarithms is to get the exponent by itself. The current price, or not the current price, this fraction would go inside the logarithm. At this point, based on what we did for the banks, you're going to have to do the change of base formula, where you would do log of this fraction divided by log of this base. Again, you could do this on the graphing calculator. You could do this on a scientific calculator. You could do this any which way. This would be log of this fraction divided by log of the base, because you do have that button. Let me show you what that would look like. In this calculator, I got log. Now, notice I closed the parentheses, divided by log. Again, you could do 1 minus 0.091 there if you wanted to. Ta-da! Now, because our rate was 9.1% per year, that means that this value of x is also measured in years. 127.88 years. Now, because we used the 995 number, this is 127 years from today. So, if I really wanted to figure this out and go the extra mile, when the question is, when will the car be worth 0, it would be the years 2147 to 2148, technically, if you really wanted to get technical about it. I would be happy with this answer, but this would be approximately when the car would round down to 0. Remember, if you have not done so already, email me the year, make, and model of the car that you want. Make sure that no one else has selected it from the Google Sheet. And make sure that it has lost value over time, and make sure that it is at least 3 years old. Now let's talk about the house. The house has certain rules, just like the car had certain rules. The car had to depreciate in value, whereas now the house has to appreciate in value. Same situation where you have to email me with the address of the house that you would like, and I can add it to the Google Sheet so that no one else is allowed to use it. Keeping in mind that you are not allowed to use the town of Random Lake, Wisconsin, as I am going to show you an example from Random Lake, Wisconsin. The current price of the house is the price that they're selling it for. The oldest price that you can find has to be at least 3 years old. Now, you might find a house that was built in like 1910. Doesn't matter. What's the oldest price that you can find under the property history? Now, if I were to go to Realtor.com, one of my suggested sites, not the only site you can go to, and type in the name of the town that I want, which I'm typing in Random Lake, Wisconsin, I find a bunch of listings of houses. Now, I could randomly try one of them and just go with that, but you have to make sure that the house has gained value over time from at least 3 years or more prior. So let's see what I can do with this. And again, I'm going to be showing you these screenshots along with what we're doing. So the first house that I chose currently is $117,900. under property history, I'm looking at the property price, not property tax, the property price. And unfortunately, this house has lost value over time. So, since I cannot do that particular house, since I cannot do that particular house, I am going to try again. Let's see, again, it doesn't matter which house you pick, just kind of pick one that you think, man, that one looks kind of nice. Let's try this one. Currently $223,400. Again, I'm not interested in the age of the house. I'm interested in the property history. Now, unfortunately, the property history, the oldest listed price is only 1 year ago, so I cannot use that. I have to go 3 years or more. This is probably going to be not the most tedious part. Not the most tedious part, but the part that you may have to spend a little bit more than a minute doing. Let's try this one. $419,900. There we go. The house is, I don't know when the house was built, but the oldest price that they give me for the house is in 2011, which means that the X value that I'm going to be using here is 9. Now, don't worry about the month and the day, just worry about the number of years. Just worry about the year. I'll show you the screenshot. The current value of the home, the resulting value of the home, is $419,900. Now, I say the initial value because this is the initial value starting in 2011. It was listed at $339,900. This house has clearly gained value over time. And I'm not going to give you write down the address, but this is Random Lake, Wisconsin. You don't have to pick a house in Barnegat. You don't have to pick a house in New Jersey. You can pick a house anywhere in the United States that you want as long as you have the evidence to show these numbers. The address, the oldest listed price, the current price has to have gone up, and it has to be at least 3 years. Now, again, I don't care when the house was built. I'm just looking for the oldest listed price. Sometimes you may find one where the initial price was like really super cheap, and that's probably because it was an empty lot to begin with, and then they built the house on top of that. Be careful. I would stay away from those because that doesn't actually show the appreciation of the house over time. That just shows the appreciation of the land over time. So we need to calculate the rate of appreciation, the rate of growth. Similar situation that we did before, except now we are using the following formula. If you plug in the numbers into their appropriate location, you can see that we still have to solve for R. We still have to get the rate of growth. And it's going to be a very similar situation that we did before. First, we're going to start by dividing by the initial value. Again, crazy decimal, but I do not care what this decimal is. I'm just going to leave it as a fraction. Just going to leave it as a fraction and let the calculator take care of the rest. I still have to get that 9 off the problem. In order to get the 9 off the problem, I'm going to have to take either a 9th root, or I can raise both sides to the 1 over 9 power. If I raise both sides to the 1 over 9 power, that means that this fraction is going to be written like that, and on the right side, you would just be left with 1 plus r. Last time I had to take care of the 1 and a minus sign, but now I just have to take care of the 1. But let's actually do this calculation and see what happens. If I zoom in on the calculator a little bit, let's get rid of those. I'm going to have to do the fraction, parentheses will save your life, 419,900 divided by 339,900, close those parentheses, raised to the power of 1 divided by 9 in their own set of parentheses. Now this is not our answer. This answer is equal to 1 plus r. So, if I were to set this up properly, this decimal, which is approximately 1.024, is approximately equal to 1 plus r. If I subtract 1 from both sides, I get 0.024, which means that 2.4% is my rate of growth, my rate of appreciation over time. Now we're going to have to do some calculations using that particular number. Now that we have the rate of appreciation, we have to find the price of the home 10 years from today. Similar to that of when we had the rate of decay for the car, we can do this particular calculation in one of two ways. We can either do it from the current price or from the oldest price that we found. If we did it from the oldest price that we found, that would be the $339,900. Setting this up. Now this is the oldest price found in 2011. So if we were going to do 10 years into the future, we would have to raise this to the 19th power. If we were going to do it from today's price is $419,900. If we were going to do 10 years from today, that would just simply be a 10. Now again, these two calculations are going to get slightly different answers, but the difference should be, well, small, to say the least. Let's try it with the 419,000. Roughly 532,286 and change. We'll round that in a minute. And then if we were to do it with the oldest price available, see, these prices are, again, just a little bit off. They're off by maybe like $1,000 or so. But again, the difference is small compared to the overall value of the home. You do not have to do both calculations. You only have to do one of the two calculations. If we did it with the price from today, we got approximately 532,286, and I'm going to round up 49 cents. And if we were to do it using the oldest price available, we got $533,396.72. Obviously, a little bit of a difference, but that's kind of rounding error when you deal with a decimal that actually does go on quite a ways. Oh, let me zoom out for that. There we go. Much better. Cool. Finally, with the house, using that 2.4% rate of growth, rate of appreciation, you are going to have to find out when the home will triple in value. Now, in the instructions for the project, I say triple in value from the current value, from today's value. So today's value is the $419,900 for our house in Random Lake, Wisconsin. 419,900 tripled. I'm just multiplying it by 3. Notice I'm not actually doing that calculation just yet. Equals 419,900, parentheses 1 plus 0.024 to the x power, because the question is asking when will it triple in value, meaning that we have to find out how many years that will take. Now, the reason why I didn't do this calculation on the left is because your first step would be to divide by this 419,900. And if you do, both sides of the equation, they technically cancel each other out when you divide. So if you did that, you'd be left with 3 equals, parentheses 1 plus 0.024 to the x power. Much easier calculation. Of course, you could make that a 1.024. I don't know why I didn't do that before, but that is what it is. But at this point, I'm going to convert to logarithms. If you were to convert to logarithms, again, the base on the log is going to be the base on the exponential. Log base 1.024. Logarithms allow you to get the exponent by itself. 3 goes in that blank spot. Again, change a base formula. Instead of writing out the I'll write it out to the... I'll write it under... Yeah, I'll just do it. Log of 3 over log of 1.024. Whatever this calculation gets is going to be the number of years that it will take for the house to triple in value from today's price. So, if I were to go to the calculator, log of 3 divided by log of 1.024 gets you approximately 46.3 years. Now, again, this would be the answer that would be perfectly acceptable. That's how many years would have to go by for the current value of the house to triple in value if the 2.4% rate of appreciation were to be consistent on average from year to year to year to year to year. If you really wanted to go detailed, you could say between the years 2066 to 2067, you can if you want to, you don't have to. This is sufficient because it's the number of years from this year, from today. Finally, the last part is a reflection. The last part is a general reflection of your opinions. Now, I don't just want a sentence per question. I really would like you to put some thought into those questions that are in the directions for the project itself. Obviously, your final product is going to have to be shared to me online via Google Drive. Some people have done slides. Some people have done just Google Docs. Whatever you end up having in the Google Drive, please make sure that you also include the evidence, the mathematical work that you did. The mathematical work can be handwritten. Just scan it, take a picture, include it into your project. And then, of course, the scoring rubric is at the bottom of that project. Make sure that when you share it with me, you allow me to view and edit it. I do look at the revision history. And if you have any questions, please make sure you send me an email. Please make sure you do. I am going to be home during this quarantine, for the lack of a better term, and I will answer your emails within a reasonable amount of time. And hope to hear from you guys soon.